Welcome to the new Industrialist. I'm Adam Bogobovic, and I'll be your host and guide through a series of conversations about mobility, energy, and manufacturing. The new innovations, the new technology that's coming that's going to change our world and our lives. And today I'm here with Ash Sethi. Ash is a program director for Pave 360 at Siemens. Ash, it's great to have you on the show.
Thank you for inviting me.
And I know this is quite a special day for you. We are at CES, and you guys just had an amazing set of announcements with Roland Busch yesterday, Satya being part of the conversation, Jay joining the dialogue. Tell me a little bit about it.
Yeah, I mean, it was really exciting. We announced quite a lot of things. And one of the focus for what we're doing with Pave 360 is was part of that announcement in that looking at how we bring the digital twin to the automotive segment and have that be something that those automakers can actually use to accelerate their own development, to create cars that we all want to drive.
And this is unique now because the competition in the market is changing. The dynamic of the market is changing. Can you give me a little bit more like the background of why does it matter? Why 360 is the product you want to release now?
Yeah, I mean, we're in a very disruptive period for automakers. Really all started with, the days where we had chip shortages and, automakers really lost control of what it was they were trying to do. So that was one piece. The second piece was the introduction of electric vehicles. And electric vehicles essentially removed the barrier to entry for a lot of new companies to come in, because now you don't need to build combustion engines, you don't need to do all of the complex mechanical stuff that was typical.
Software becomes now way more important.
And the software becomes hugely important, and consumers are also looking for their cars to be more like their phones than the driving experience, if you like. They just want to get from A to B, but they want to do it in comfort, and they want to do it with all of the technology that surrounds them.
And then what's the role of Pave 360? What's the role of Siemens in being part of this new competitive environment?
So as soon as you get into this position where software becomes the most important thing of the product, you now need to develop that software quickly, you need to develop it easily, you need to be able to validate it, and there's so much of it that you really need to be able to get through that. And the traditional way of developing software for automotive was that you would have a supplier or a group or a team that would come and deliver you a box of hardware, and you would then develop your software on top of that box. Now, that doesn't work anymore, because the amount of software that has to be developed, it now takes over the project scale.
And there's more than one box.
And there's many boxes that are now being integrated into a single one or two boxes. And what does that mean? Well, that means much more performance in terms of the CPU power that's needed in the box, and more software integration. So it's actually just adding to the problem, combining all of these boxes in.
So for the audience, just so everybody knows, when we say boxes, we mean computers, we mean PCs, servers.
What used to be small computers, 106, 107, 130 of them dotted all around the car, turning into 2 or 3 very large computers, very powerful computers, that are essential to the function of all of the features of the car. So all of this software that needs to be developed had to wait for the hardware to become available, and now your software takes longer than your hardware, and all of a sudden you're talking about a 5-year development.
So that's a complete shift. The hardware development is now easier and simpler, the physical body of the car and the hardware for the compute, than the actual software, the logic that goes into it.
Exactly. And so what these automakers are looking for, and what they desire and what they really need, is the ability to create that software without having to wait for that hardware. And what does that mean? Well, that means you need a digital twin so that you can actually put the software on the digital twin, do the development work, and validate all of it before the hardware comes along.
Okay, but how does it work? What does it mean to build a digital twin, and why can you work with it faster than you would have if it was a piece of software you're writing for a hardware component?
Sure, and digital twins of a sort have been around for quite a few decades, and really what I'm talking about here are models of processors that you can use to execute the software that you would design that went into a car or anything else, really. those models, as the compute power starts to rise and we get up from 300 megahertz CPUs up into gigahertz plus CPUs, those models that have been available for decades are way too slow, and software developers can't work with.
What does it mean, way too slow? Like, how long does it take? What is fast and what is slow?
If you want to run some software, so you're writing an application, let's say, I don't know, a media player or something like that, right? When you write the code and you compile it, then you want to run that code, right? You want to run that application. Now, typically you would do that on a piece of hardware, but now the hardware doesn't exist, so you're going to run that on a model of that hardware. But that model in previous times has been very, very slow in executing that software. So your software developer is sitting around waiting for this thing to complete its execution in order for him to go and debug it.
Well, sitting for seconds, for minutes, sitting for months?
We're talking about anything from minutes to tens of minutes, depending upon how complex the software is.
And I would assume you have to run this process multiple times as a developer. It's not a one-time.
Yeah, and developers are write some code, compile it, run it, debug it, write some code, compile it, run it, debug it. The cycle is hundreds and hundreds of times in days, right? So it really slows down productivity when you're dealing with that kind of bottleneck.
So to solve this, you need a model, which is what you are building, and you probably also need the compute power to be able to process all that model logic.
Quite right. Those two pieces need to come together. And we've done the modeling, and the cloud infrastructure from Azure has the compute power and the capacity to be able to run those models at real-time speeds. So we've created the technology to run those models at real-time speeds. That gives those developers the feeling that they're creating that software on real hardware. And what we recently announced a few weeks ago, just prior to CES, was the introduction of Pave 360 Automotive, which is a automotive specific platform running Pave 360 toolsets that gives developers all of the pieces, the models, and the entire system, the vehicle network, everything that they need to create this holistic big CPU box that would go in the car to advance the whole concept of SDV.
So what if I'm a developer and I'm watching this conversation? What does it really mean to me? How do I enter into this system, this completely virtualized system that I can now use?
And that's a very good point, because you have a lot of automakers who don't really have experience with digital twins. And we have worked with automakers developing custom digital twins for 3, 4, 5 years, and we've delivered quite a few of them. And our learning from that is that if you don't have the right skill sets, if you don't have the right team and the capacity, it could take you 2, 3 years to even bring up a digital twin. So what we've done with Pave 360 Automotive is we've built the digital twin for customers, integrated it, tested it, added a whole bunch of reference software, such that a developer who gets access to this, and the access is via cloud, but can also be on premise. When a developer gets access to that, it's a 1 hour bring up time. So
you build more than a framework. You actually build a complete solution that somebody can use.
Built a complete solution which is available as a product that a customer can bring up in an hour.
Is there anything that a developer or a customer would need to know to be more ready to use this solution? Is a particular development skill set, tool set that if they worked before, it will be easier for them to work with it now?
Not really, because what we're really doing is we're saying, use your existing environment, right? All of the things that you're used to as a software developer, just use those, but instead of programming the hardware, you're going to program on a digital twin which runs in the cloud. So, really, it is as simple as swapping the hardware out.
And then, obviously, you must have modeled some different types of hardware. Is there a library of models that you are using, or is it somebody has to remodel their particular hardware component to be able to use the tooling that you have for them?
It's a flexible platform, so it's customizable, meaning that our customers can add their models in if they wish to. But there's a reference set, essentially, which is delivered with Pave 360 Automotive, that they can get started immediately with that reference set, and then go in and customize hardware, software, have that interplay between the hardware and the software, and adjust and make it their own.
So at the beginning of our conversation, you said, building the software set could take years. what does it mean with the tools like that you were building? Like how quickly, how much of a difference are you making in the life of somebody building software for a vehicle?
Well, instead of a digital twin user having to spend 3 years creating the digital twin before they can write a single line of code, they can do that on day one.
So the upfront piece is gone. But now you're writing code for the specific vehicle. Is that easier? Is that faster too?
The important piece is it needs to be the same as they would have done if they had hardware. So we're not, helping them or changing the way in which they're going to write that code. They're just going to write that code in the way they would normally write it on if they were running on hardware.
Verification of that code will be easier.
Verification is easier. Validation is easier because we have the capability to plug real-world stimulus from, again, virtual scenarios into that digital twin. That comes as part of the package. And increasingly, I think we even heard this from Roland and Jensen in the keynote, opening keynote at CES, that great to have a digital twin of the product, but if you're not stimulating that product with a digital twin of its environment, then it kind of you're losing some of the value of working with digital twin. So the idea here is that you want to have a digital twin of the automotive electronics and a digital twin of the roads, the streets, the city, even other cars, pedestrians, etc., such that you can actually test that digital twin.
So now you're making it way more sophisticated. Now you're going towards autonomy. Is that the step towards that direction?
Yeah, and some of the work that we're doing with Microsoft is kind of in that direction, whereby we are, all of this, the environment, essentially the environmental stimulus, the scenario. So imagine, a car driving through streets in Vegas. We can create a map of Vegas, and the car can, the virtual car, the digital twin of the car can drive through a digital twin of Las Vegas and actually start sort of interacting with that environment. And you can, as a user, as a software developer, as a verification engineer, actually apply test cases and test scenarios into that whole system and not have to actually take a physical car and drive around Vegas in order to test things
Not that
out.
anybody would want to. I just, came on a cab here. So yes, it's a complex environment to simulate.
Just imagine that cab is a self-driving cab. Yeah, you'll scare yourself.
Going back to collaboration that you have with us, what's the role of Microsoft? Why did you pick Azure, and what's the function of Azure in that process that you are describing here?
Sure. So, we're fully cognizant of the fact that our customers have a choice in terms of cloud providers, etc. And Azure, a leader in the industry, right? It would not make sense for us not to be working with Microsoft. So, when we started the discussions, it became obvious that we needed to take what we'd done, what I just described, and actually apply that using the Azure cloud. And that's what we did. We demonstrated part of that last year, and we've advanced that this year. And things are looking bright.
That's awesome to hear. Do you have first customers on Pave 360 using the technology, the modeling, the virtual twin already?
Absolutely. We have a wide range of customers across the industry. So, anywhere from semiconductor providers all the way up through tier ones and OEMs, and even we have self-driving service providers that we're talking to that are interested in the digital twin environment extending to how the service plays out with autonomous vehicles, in various different environments.
And if you talk to one of them, what is their perspective on this solution? How would they describe what you are building?
So several demonstrations we've done to several customers, and several customers who we've worked with in the past have essentially come to us and said, this is exactly what we need. Automakers, as I said at the beginning, were struggling essentially to get the amount of software out that they needed to get out and compete. And so the digital twin is something that gives them that capability, and they're eating it up. It is a turning point, I would say, in automotive industry and development.
So I want to take a perspective of folks listening to the show here. Customers are already embracing this new way of thinking about automotive as a space, building software for cars, the rethinking of what hardware looks like, what software looks like, how do both of these things come together. What does it mean for consumers? What does it mean for you and I when we drive a car? will our cars be different? What will change for somebody who doesn't know the technology but cares about how they get to work every day?
Absolutely. I mean, there's going to be plenty of viewers who have gotten into their cars and tried to connect their phones. It there'll be plenty of viewers who have gotten into their cars and, a year in, 2 years in, they've had to take it back because, I don't know, the air conditioning doesn't work properly, or all of these little niggles are because the software isn't running in the way that it should. And there have been many recalls of many cars over the past decades or so that have the causes for which have been the software. So consumers are going to get cars that are empowered with huge amounts of software, that are cloud connected, that are interconnected with each other. And the experience of leaving your home, getting into your car, and having seamless kind of experience between home, phone, car, office, work, life, all those kinds of things. That is what we think is going to happen in the future, and consumers are going to lap it up.
And we also know that software develops and changes so much faster than hardware can. So I would assume that not just it's going to get better in terms of not breaking on us, which obviously we all care, we don't want the software-related recalls, but I also would assume there's going to be new things that the software will be able to do in a car. Are you already envisioning of what that could be?
Yeah, so car makers are looking for new sources of revenue, and app stores and new apps that could be running in the car that would deliver consumers with new services, and they're all part of that new revenue stream strategy. And users are going to experience their car being more like an app store. So all of that software that is delivered with the car when you purchase it is going to be very, very different from the software that you have in that car 3 years down the road. There would be over-the-air updates for the base software. There's going to be app stores and applications that users will download, purchase, and use in their cars. That could be, I mean, I've said examples of this before, but an autonomous vehicle essentially has eyes. Even an advanced ADAS vehicle has eyes, and it can interact with the environment that it's driving down. Now, just imagine driving down the street, and your car sees a Starbucks, and your in-car software is loaded with the Starbucks app, right? When the car sees the Starbucks sign, it can, contact the cloud, contact Starbucks. Starbucks loads you up with a voucher, discount voucher, or something like that.
Understand your context, because maybe you don't drink Starbucks, maybe you drink coffee from somewhere else.
Yeah,
there's a new level of intelligence that we are bringing into,
exactly.
that you are helping to bring
So
into the automotive
discount for
space.
coffee, and maybe even the car finds you a parking space. Right, autonomously drives into a parking space, stops, you get out, go grab your coffee, get back in, and you're on your way again. It's, things like that are interesting.
Okay, so now you're bringing another layer of thinking here. AI is coming into cars, not just the apps and the software itself. The way you think about building software, are you also thinking about building software with intelligence?
Yes, absolutely. I think in intelligence in terms of AI in vehicles is essential. There's no way to get around it. A car cannot, perform object detection and, see things without having that AI capability. That means more software. That means bigger hardware, more powerful hardware. That means all of those things that are being experienced all around the world with all the other AI applications that are coming through. Using a digital twin to develop AI, it is almost essential, because the amount of data that you have to throw through an AI model is huge, and you're not going to drive the car around city streets for 10 million miles to gather that data up. You're going to do that in a virtual and a digital
and
landscape.
that has to reside within the model.
Has to be in a model, has to be in a digital twin.
It's a fascinating conversation and a really interesting insight into the future. Is there a question that I did not yet ask you and I should have?
That one. No, I don't think so. I mean, I think what we're doing with the Azure cloud is going to open a few more doors in terms of how we bring this digital twin, how we end up changing the industry. That's really what we're trying to do.
Thank you so much. Congratulations again on an amazing CES, all the announcements you had, and thank you for the conversation. It was a real pleasure.
Very welcome. Thank you very much.
Thank you.